Your last video in your series of tutorials is on its way. We are going to be reviewing the steps to carry out a Gay-Lussac's law problem to solve for an unknown variable of a gas. So if you recall from our Boyle's law tutorial, we had our 4 different variables here. We have P for pressure, V for volume, N is the amount of gas, and T is temperature. For Gay-Lussac's law, the things that we hold constant are volume and the number of moles. And therefore, pressure and temperature are the variables that we will be using in our discussions and in our calculations for Gay-Lussac's law. Okay? Whenever, if you remember from the demo that you just watched with the oil drum or the steel drum, they had increased the temperature by boiling some water into water vapor, and that was that resulted in an increase in pressure. So when they increased the temperature, the pressure also increased. And then they put that oil drum into an ice bath to kind of cool it off. That didn't work right away, so they started spraying it down with a hose. So they were trying to decrease that temperature. And then you saw that oil drum collapsed on itself, and that was because the pressure also decreased, so much so that the atmospheric pressure crushed the can. So because both of these variables went up, or both of them went down, similar to Charles's law, this is a direct relationship, which means that we are going to have a similar equation to Charles's law, which is P1 over T1 equals P2 over T2. Okay, so if you remember from Charles's law, the volumes were on top, temperatures on bottom. So Gay-Lussac's law is pressures on top, temperatures on bottom. That way we can see what an unknown variable is if we change one of them, okay, or both of them, I guess. And since we're using temperature here, remember that degrees Celsius must always be converted into Kelvin using degrees Celsius plus 273. Okay, so we discussed that in the Charles's law video. Alright, so now to move on to a problem, let's scooch this up here so we have our equation. Alright, so here we have, it says a container full of gas has a pressure of 3.2 psi at 33 degrees Celsius. If the temperature increases to 101.6 degrees Celsius, what is the final pressure? Okay, so once again here we have to go through and we're going to look for our variables. PSI I know is a unit for pressure, so here we have 3.2 psi, so that's going to be our P1, and that is at 33 degrees Celsius, so we're going to make that our T1. And then if the temperature increases, what should happen to the pressure? Well, up here states that if the temperature increases, that the pressure should also increase. So that's something to keep in mind as you are proceeding through your problem. Okay, so our temperature increases to 101.6 degrees Celsius, so that's going to be our T2. And then we are looking to solve for our P2, so that is our unknown. Okay, the first thing I want to do is I want to convert these temperatures into Kelvin. So 33 degrees Celsius plus 273. Let's get out our calculator here. We've got 33 plus 273. That gives us 306 Kelvin. And then our next one is 101.6 plus 273. And there we get 374.6 Kelvin. So now we've got our two temperatures into our Kelvin scale. Now to plug them in. Let me give myself some more room here. Okay, so we're just going to plug it right into that equation. If we have P1 over T1, sorry for the parentheses, means the same thing. Our P1 here is going to be 3.2 psi. We're going to divide that by our T1, which we converted to 306 Kelvin. We're going to set that equal to our P2, which we do not know, so P2 is going to go on top. And then our T2 is going to go on the bottom here, which is 374.6 Kelvin. Okay, so we have to cross multiply again, so this expands out to 374.6 Kelvin times by 3.2 psi equals P2 times that by 306 Kelvin. Okay, now since we're wanting to solve for our P2, we have to divide both sides by 306 Kelvin. So here it's going to cancel out. We're going to be left with our P2. And then this whole thing is what we can plug into our calculator. Okay, so if we have 374.6 times by 3.2 psi divided by 306 Kelvin, we get that our answer is 3.917. We can use 2 sig figs, so that's going to round to 3.9. And because our initial pressure was in psi, then our final pressure is also going to be in psi. Okay? And so very similar to Charles's law, except for we're using pressures instead of temperatures. So hopefully that helped you, and good luck on your assessment.